This video is on systems of equations. We're going to be solving by graphing. The first step when you are solving by graphing is to look at the equations. Are they both in y equals mx plus b form? So we need to have them in slope-intercept form because we're going to be solving a system of linear equations. So if both of the equations are in slope-intercept form, we can go ahead and go to step 2, which is graph both equations, just normal. But if they are not both in slope-intercept form, we have to make sure we rewrite them into slope-intercept form. So this first problem, 6x minus 2y equals 8 and y equals x minus 2. Both of them are not in slope-intercept form, so we need to rewrite them. So we're going to follow this side. No. So the first equation of 6x minus 2y equals 8 needs to be rewritten in slope-intercept form. The first step is to subtract the 6x from both sides, and we'll be left with negative 2y equals negative 6x plus 8. We could put it as 8 minus 6x as well, or we can write it as negative 6x plus 8. The next step would be to divide everything by negative 2. And we will have y equals negative 6 divided by negative 2 is a positive 3x, and a positive 8 divided by negative 2 is a negative 4. This is now the first equation we're going to use. The second equation, y equals x minus 2, is already in slope-intercept form, so that means that our second graph will be y equals x minus 2. We're going to then, once we have both of them in slope-intercept form, step 2 is to graph both equations. So we're going to graph the first line, y equals 3x minus 4 in pink. So my first coordinate will be at 0, negative 4. My slope is 3, so that's change in y of positive 3, 1, 2, 3, and change of x of positive 1. I'm going to do that until I can't go any further. Change in y of positive 3, 1, 2, 3, change in x of positive 1. 1, 2, 3, 1. I can't go any further up, so I'm going to try and go down. So I'm going to do a change in y of negative 3 and change in x of negative 1, because a negative divided by negative is still a positive. So now that I have all of these coordinates graphed, I can then connect my coordinates with arrows. Not the same color, but that's okay. As best as possible. So I can then move this over some. So now I have all of my line is graphed. So next, I'll graph my second equation. My first coordinate is at 0, negative 2. And my slope is positive 1. So that means a change in y of positive 1, change in x of positive 1. Change in y of positive 1, change in x of positive 1. So I'll do this as much as I can, all the way to the edge. Then I'll go and change in y of negative 1, change in x of negative 1. That way a negative divided by negative is still a positive. So I can still get as many coordinates as possible. And since this is an equation, we know that the line should be solid. I'll connect these again. It's not the exact same color, but close enough. And doing this on paper, I would probably have a ruler, so I would have a straight edge, so I could easily connect the dots without having an actual line part here. So once we've graphed them, we'll go to step 3, locate the point of intersection. So I'm going to actually find this location of where these two lines cross. These two lines cross at a coordinate of 1, negative 1. So 1, negative 1. This is the point of intersection. Step 4 is to check the solution. So our solution is 1, negative 1. So this is an x and this is a y. So to check the solution, we plug them into the original equations. So the first equation, if we go back to the problem, was 6x minus 2y equals 8. So 6x minus 2y equals 8. And the second equation was y equals x minus 2. We're using the original equations instead of the ones we solved slope-intercept form for, because these were always going to be the givens. If we messed up putting it into slope-intercept form, then our solution will be wrong, but if we plugged our solution into our messed up equations, it would say it's right. We always want to plug our solution into the original problems to see if our solution is in fact correct. So our x is 1 and our y is negative 1. So we're going to plug them in. So 6 parentheses, negative 2 parentheses equals 8. We're going to plug in the x of 1 and the y of negative 1. Then we're going to simplify this. 6 times 1 is 6. Negative 2 times negative 1 is positive 2. It's supposed to equal to 8. 6 plus 2 is 8. 8 does equal to 8. So that means that for the first equation, it does check. But it has to check for both. So we're going to do the same thing. We're going to plug in our y value of negative 1 equals our x value of positive 1 minus 2. So we have negative 1 equals 1 minus 2. Negative 1 equals 1 minus 2 is negative 1. Negative 1 does equal to negative 1, therefore our solution of 1, negative 1 works. So to solve systems of equations, of linear equations by graphing, is we graph both of the equations and then we just find the point of intersection. Now we can also do this using Desmos. So if I'm going to use Desmos, I'm going to type in the original equation of 6x, I'm going to take the caps off, 6x minus 2y equals 8, and then I'll have y equals x minus 2. Do my little home screen. So my 6x minus 2y is in black, and my y equals x minus 2 is in red. I can see where these two lines cross is at 1, negative 1. I get the exact same answer, but I did not have to put them into slope-intercept form if I am using Desmos. If I am graphing it by hand, I must have them in slope-intercept form. And that is how we solve systems of equations by graphing.